Hey everybody, this is Larry. This is me doing a bonus question, a problem that I haven't done before on Leetcode. Hit the like button, hit the subscribe button, join me on Discord. Let me know what you think about today's randomness. Let's see which one we are we going to get. Ooh, all one status structure. All one. What is this English? All one data structure. Okay, so yeah, today we're gonna get a hard problem. Hopefully this is gonna be fun. Let's take a look. Design a data structure to store the strings count with the ability to return the strings and with minimum and maximum counts. Not sure what that means yet still, but also just want to say, weekend is here, so hope y'all are having a good weekend coming up. I've been rushing through the intro a little bit lately, but you know, hope y'all have a great weekend. Hope y'all have a great week. Summer's almost over, so yeah. Hope everyone's just enjoying themselves and and yeah. Um, yeah. Okay, cool. Let's see what this all one actually is. So have I haven't done this before, right? It feels some familiar, but I don't know. Though the title name is a little bit weird. Okay, so all one initialize, increment to count the string of key by one. What is that? I mean, we have a key increment. Okay. Decrement, get max key. Okay, so maybe that's the tricky part. Return one of the keys of the maximal count. Okay, get one the minimum key of the maximal count. Minimum count. I mean, this is very weird. I don't get why is what does the definition mean? All one? Hmm. Oh, I guess it has to be done in O of one. I guess maybe that's the tricky part. All of one data structure. I get it now, but there's I don't know what happened here. Um, well, first of all, it's going to be depending on how you want to say all of one. It's a little bit awkward, right? Because incrementing by key is always going to be O of L, where L is the length of the key. That's just the size of the input. You can't really do better than that, no matter what. And also, this is going to be O of L as well. Okay. And then the question is, let's see. The question is, okay, the maximum and the minimum count. The maximum count, I think, is easier. You can just keep. Well, is that even true? Mm, don't know if that's true actually. I was gonna say like you could just keep track of things in a good way, but maybe it's not that simple because when you delete stuff, your max can change. But no, I mean I think that's fine. I think this is all just bubble sort, right? Um, yeah, I mean it's not a easy bubble sort, but it's a possible bubble sort, and you can do that with um so yeah, so you do bubble sort on either linked list or something like that. Maybe you don't even have to. You just kind of make sure you keep track of it. No, I mean, yeah, I think that's fine. I think it's annoying but possible. So yeah. Okay, let me give it a try. I think we have the idea, but it's a little bit. So we have a lookup table. Basically, this looks up the index of the stuff, and then we have a sorted list. We're not going to use sorted list here because it won't even be fast enough. But this is just basically the idea. Okay, so then increment. So if key is not in self.lookup, so one other thing is that if it's not in the lookup, then we have to keep track. But the part of that invariant is that you're not inserting an arbitrary key, right? Or actually, I want this to be a deck. Is that true? Because I want to add in the front and end. Maybe we have to change some data structure, but the idea is going to be right, I think. But yeah, if the idea here is that you always only increment from the beginning, so that's fine. So if this is not then self.lookup of Actually, I don't know. I mean, it's still true, but because I think the right way to do this is using a linked list, and I mean I'm trying to use it with all these things. What you should do is have a linked list, and this points to the pointer directly. So we'll use a doubly linked list here. Let's do that, and then yeah. So let's say we have a node, we have let's say a key and a value or something like that. Right. To be honest, I was just being lazy because I think I knew that I need to do this anyway. But so something like this, right? So a doubly linked list, and then we have a self.lookup, and then we have a head is equal to, just a regular whatever, right? Like a sentinel head, and then for increment, if this is not in the key, we do self.lookup of key is equal to a new node of value key and 1 because we have one element. And then here, because we're increment, here we will let's see, add to the beginning, right? So self.head, because it is a sorted list, so self.head dot next is equal to how do I say this? It's going to be equal to this thing, but not quite, right? Because you need to insert it. So okay, so previous next is equal to self.head.next, and then we do this thing, and then self.lookup of key.next is equal to previous next. But then now this is a doubly linked list, right? So we have to keep track of that as well. And hopefully my explanation is pretty okay, in a sense that I think this is just being really careful, one step at a time, right? So here now previous next dot previous is equal to self.lookup of key. Maybe I should just write this as a node. So much typing and so much lookup. So yeah, node is equal to this, right? Yeah, and we might think about ways to make this a little bit cleaner, but for now, let's just focus on getting it right and going through being exhaustive. But yeah, it's equal to node, and then node.previous is equal to self.head. Yeah, so this is just changing back to back. Okay, so that's good. Else, if key is in it, then we go node is equal to self.lookup of key, and then node.value we increment by 1. So that means that now, as we said, it's kind of like a I want to say this is kind of like a bubble sort, but maybe this is a little bit wrong, or it may be too slow, even though it may be O of, we have to be a little bit smarter to get it to be O of 1. So that's a little bit awkward, because for example, you can have like, I don't know, let's say you have A, B, C, and then you keep on, you increment by 1, so then now you move to A to BCA, and then now you move to B to CAB or something like this, and then increment to C, and then you have BC. Now it's not O of 1 every loop. So I think we're a little bit off here. You have to do some sort of like speeding it up type thing. But that's basically the idea. Because the way that you would fix this is by just more bookkeeping, really. Maybe I'm doing this in a funky way. Maybe I could do this in another way. I think the way that we can do this is fine, but I think that the cost is amortized is not quite right. Like what we want is maybe just more tracking. And what I mean by that is we can maybe do something just like that, and then and then we just have like a second counts away or something like this. And then basically if key is not in lookup, then lookup of key is equal to, or is it lookup? No, this is just count. This is counts. Whoops. And then we can do something like, and this is self.counts. And then we can do self.lookup. Well, it didn't exist before, but now the one we can append key, right? And then else, if it is in there, then, well, self.counts of key we increment by 1. And then here we do self.lookup of, oh, then we want this to be a set. So we actually want add. We have to do a little bit. We want a collection start default dict of a set. We add this key, and then we here on the previous number. So here we remove first key, and then here we add back afterwards, right? Okay, I think this is fine for increment. And then decrement, we go if, and we have to keep track of the max and the min. So, and that's fine, but yeah, if, let's see. Oh, it guarantees that it exists. Okay, so if key has to be in it then, right? So self.counts of key subtract by 1. We can do this thing again, and then, you know, here we go if self.counts of key is not 0, then we do this thing, we add it back. If it is equal to 0 though, then self.counts, we want to delete it from existing altogether. And I think this part we're good. So get max, we might have to keep track. Basically, the only place that it will get maxer is here. So yeah. Let me think about this, right? But we just have to keep track. I don't think there's, you know, right? So, okay. So if self.counts of key is greater than max index, then self.max index is equal to self.counts of key, right? That part is fine. Min is a little bit tricky. We might have to think about it a little bit. But let's do this one first. So here you go, basically, if self.counts of key is equal to self.max index, so if this is the max and we remove it, and length of this thing is equal to 0, then self.max index also -1, right? Because now we just go up down here. So then now we just have to return self.lookup of self.max index, and then we just take this first element. If no element exists, return empty string, fine. If okay, fine. Return empty string, and then getting min is the tricky one. Because okay, so yeah, if this happens, then this is always going to be min, just because that's how min index works. And then incrementing it would that change? Basically, it's just more if statements, I guess. If self.min index is equal to this number. Wait, did I do that right? I think this is right. It's equal to this number. So if this is equal to this, and now the length of this is 0, then we are incrementing it, right? Because that means that the new min get incremented. Okay, so then now decrementing. So this is the max index, but also if this is the min index, maybe. Maybe I add this. If this is the min index and we subtract, then we subtract by 1. Right? Is that right? Trying to think whether there's a case where this is just not right. Well, if it goes from 1 to 0, is where this is not right. But then the min index would be 0, I guess. So yeah, so I think we can now just copy and paste this for a little bit. Let's give it a spin. Am I confident? Not at all. But yeah. Set is not subscribable. I have to do like no, but if I convert it to list, this is expensive, right? Let me see. Set first item. I think you can do like a first or something like that, or next item or something. Let me see. Because if you create it to a list, that's not great. Okay, so it's just next. Let's see. That's just syntax thing. Okay, so I am. So that does not make me feel confident because I don't know. I don't think that this is a very good. I don't think this is a very good example at all. That type of stuff. But I am lazy, so I'm just gonna submit and then use TDD if you want to say for practice. Yeah, and as expected. Let's see. So basically, I increment, and then max key is already not working. Why is max key already not working? Oh, huh. This is dumb. Okay, if self.max index is less than it's less than 1, then wow, that is pretty bad actually. I mean, I just never said it here. I think that's really it. All right, let's give it a submit again. I'm expecting like 4 wrong answers for this problem. Just because I'm a little bit lazy today. But let's see. Huh. Seems like I'm making very silly. I mean, this is just all bookkeeping and making sure that we track all the states of everything. So it's very easy to be off by 1. But so we'll see. So get min key in the. So this definitely is wrong. That means that we don't keep track of min key in a good way. Oh, wait, no. I just scrolled it up. Okay. Let's see. Why is that? So increment all the way until here. So basically you have 1A, 4B, 3C. Right, and then we decrement the A. We have min key and it's gonna be A. We get rid of it and then max key. Why is max key C? Oh no, because the 2 B's are decremented. Okay, I missed. So that means that there is 1A, 3. So there are now 3 C's left. Oh, I see. I didn't. So basically now, if this decrements with this, but if this is 0, I don't do anything. Okay. That is tricky actually. I don't think that I considered that in a good way. Can I do this in a while loop or is that too slow? I mean, we can keep track of it to do things in an old one kind of way, but it's just messy. But I know why we're wrong, because this goes from 1 to now 0. How do I keep track of that in a good way? Right. Mm. I thought I thought about this case, but clearly I did not. Oh, maybe I thought about the min this case, but even this hack is a little bit weird. But okay. Yeah, because this case, then now we're trying to think, if we delete it and it was the min, then what do we do? No, because you always have to keep track of all of them. Mm. Hmm. Let's see. I don't. I mean, I know how to fix it. Not gonna lie. I'm just trying to figure out how to fix it in a not exhaustive kind of way. And the way that you would fix it is kind of what we'd had before with a linked list, right? So when you decrement stuff, you like not just a linked list, but like a skip list, which is what we kind of have here, but but eh, let's see, right? Maybe I could just be a little bit lazy here. If this is the case, then okay. Maybe I could do a for loop, but I think that degenerates to n square anyway. No, because for every decrement, it amortizes out. So I think maybe we're. I mean, I don't like doing it, but I think that should be fine. So yeah. If I mean, I have to do something to. But I have to do something to make sure that this isn't an infinite loop first, which is that self.counts, I guess. Okay, let's run it. So the reason why this, I think, amortized works is because this is a sort of a symmetry, right? What I mean by that is that if your min gets resetted a lot, then you need to go up. So basically, I don't know that I can say it in a good way, but let's say you have, we have A, we have C, 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 as we did before, right? Let's say we remove A, and now we have 5 C's, and then we have to do this while loop. Well, it only goes up to the number of C's that are before, so therefore, this is linear in the size of the input, because this will increment, this is amortized as the increment optation, right? Because we only go up for every for at most every character that we've seen, right? So for example, if you have like A, B, B, C, 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 D, 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 E, and so forth, right? In this case, let's say you remove A, then now you only go up twice. And then now you know, let's just say you remove B, so then it's still twice, and then now you only go up 5, right? And then now you only go up 8 or whatever. And then so I think in that way it is amortized constant. I think in my head I was trying to prove that a little bit, or just have a cleaner solution, to be honest. But yeah. As I mean, this is really yucky code. But this is going to be O of 1 for every operation, maybe O of L, depending on you want to say that's the length of the keys. But yeah, that's pretty much all I have. It's a really really annoying problem, but not difficult to understand per se. But I just had a bit of silly mistake. Well, this one was silly, and I knew that, and I mentioned this a little bit. Is that what the I mentioned this a little bit, right? Which is that I knew that this was going to be an exhaustive one. And what I mean by that is just about thinking through and executing on all the cases, which I failed twice on. So, but yeah, but this is good practice. Maybe I need to think about it a little bit more. But yeah, that's all I have with this one. Let me know what you think. Hit the like button, hit the subscribe button, join me on Discord. I'll see you later soon. Take care and goodbye. Hopefully, we'll do I think the contest is in like 11 hours or something, so we'll do it together. I'll see you soon. Bye bye.